Alright, in section 5.3 we are going to look at proving that lines are parallel. So in these examples we're going to be given some information about our angles and we have to decide if we can prove that those are parallel or not. So if a pair of lines, let's call them L and M, are cut by a transversal T, and either number 1, their alternate interior and exterior angles are congruent, number 2, their corresponding angles are congruent, and number 3, their same side interior or exterior angles are supplementary, then we can say that L and M are parallel. So let's look at an example. If we look at number 1 here, can we conclude that lines A and B are parallel? If we look at the angles that they give me, I have 52 up here and 52 down here. They are on the opposite sides of my transversal right here, and they are both outside my parallel lines. So that means I have a pair of alternate exterior angles. And they are congruent. They are both 52 degrees. So because I have a pair of alternate exterior angles that are congruent, this means yes, they are parallel. And if we look above, that was number 1. My alternate exterior angles are congruent. So that is why we can say that's parallel. Let's look at number 2. Number 2, we have 38 degrees here and 38 degrees here. These angles relate by vertical angles. Our angles are congruent because they are vertical angles, but if we look above at our rules, 1, 2, and 3, nothing talks about vertical angles. Vertical angles is not enough information to prove that my two lines are parallel, because if you look, this bottom line right here has no relation to the angles above. So this is no, because it's not enough info. Okay, let's look at 3 and 4. Here I have 70 degrees and 110 degrees. These two angles relate by being on the same side, and they are interior. Now my same side interior angles are supposed to add up to 180. They're supposed to be supplementary. So if we look at this, 110 plus 70, that does give us 180. So that means they are parallel because in number 3 up here, our same side interior angles are supplementary. Okay, last example on this page, we have 68 degrees and 68 degrees. They are on opposite sides of my transversal, so that means they're going to be alternate. And they are inside my parallel lines, so that is interior. Since they are congruent, my alternate interior angles are congruent. That is number 1 up here. So that means yes, these are parallel. Okay, for our next 4 examples, it says find the value of x to make each pair of lines parallel. So if we look at number 5, these two lines have to be parallel. That means our angle 5x here and our angle 3x plus 20, if they are both on the same side and they are inside our parallel lines, same side interior, that means they must add to 180 degrees. So in order to figure out what x is when that happens, we have to add our two angles, 5x plus 3x plus 20, and set it equal to 180. Now the only reason I'm adding these up and setting them equal to 180 is because they're supposed to be interior. So if we do that, 5x plus 3x gives me 8x plus 20. I'm going to subtract 20 from both sides. 8x equals 160. Divide by 8, and I get x is equal to 20. So this is what x would be if these two lines were parallel, because then it would make those two angles add up to 180, which is what we need for them to be parallel. Okay, let's look at number 6. Now these angles over here, they're on the same side of my transversal, but one's inside and one's outside. So if I picked up 3x minus 50, if I picked up those 4 angles in the middle there and put it on top of my other group of 4 angles at the bottom, 3x minus 50 and 2x minus 5 would be right on top of each other. That means they're in the same position, so they are corresponding angles. Corresponding angles, we know those have to be congruent in order for our lines to be parallel. So if those two angles have to be congruent, instead of setting them equal to 180 this time, I'm going to set them equal to each other. Because if they are congruent, that means they must be the same. Now I can solve this equation. So if I subtract 2x from both sides to move my x term, I get x minus 50 equals negative 5. Add 50 to both sides, and I get x equals 45. So that is what x would have to equal in order for my lines to be parallel. Okay, let's look at 7 and 8. Last two examples. My angles here, I have 110 and I have 4x plus 10. The first thing I need to do is identify how those relate. So if I look, they're both on the same side of my transversal. And they are both on the outside of my parallel lines. So that means they are exterior. Okay, so if they're same side exterior, that means that they should be congruent if my lines are parallel. So if I want them to be congruent, that means I need to set them equal to each other. Now I can get x by itself. In order to get x by itself, I'm going to subtract 10 from both sides. 100 is equal to 4x. Divide both sides by 4. And I get 25 is equal to x. So this is what my x would need to be in order for those to be parallel. Okay, last example over here, we have 6x, we have 4x plus 36. Those are both on alternate sides of my transversal, and they are both on the inside. Alternate interior, we know those need to be congruent. If they are going to be congruent, they need to be equal to each other. So if I move my 4x over to be with the 6x, I'm left with 2x is equal to 36. Divide both sides by 2. X is equal to 18.